All right, good morning. So today we are going to talk about how we can see if a line is perpendicular, and more specifically, if it's a perpendicular bisector. Okay, so if we look here, it says, in a plane, if its point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if we look here, CD, if it's perpendicular bisector, which hopefully we remember, perpendicular is when they form kind of like my cursor here, they cross forming right angles. Okay, so we know that's perpendicular because of that right angle there. And it says it's a bisector, meaning from A to D and B to D would have to be the same length. And we know that that is the case if from C to A and C to B is equidistant, which if we're not sure what that means, equa sounds like equal, distant sounds like distance, so equal distance or congruent. Do you see these marks? So we know they are congruent. Okay. And then likewise, if we look here, it says if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So C is equal distance from A and B, so we know this is the perpendicular bisector. So example 1, it says, is BD perpendicular to AC? So BD, is B the same distance from A and C? Yes, then BD would have to be the perpendicular bisector. Now, if we're not sure why, remember BA is congruent to BC. So yes, because BA is congruent to BC. And also then we know that D is in the middle because AD and CD are congruent. Okay, and so that has to be a bisector. We know this will be a right angle then, or perpendicular. So find the value of each variable here. Do you see how BD is the perpendicular bisector because there's a 4 and a 4, so those are the same. It's a right angle, so we know then that from B to A and B to C are the same. So we look here, B would have to equal 6, and we're done. Now in the next one, if B to A and B to C are both 12, then BD is a bisector, or a perpendicular bisector. And so then we know that R has to be 8. All right. Example C here. 4A plus 11 will have to be equal to 27 in our case. Because these are the same, it's a perpendicular because of this right angle, so we know those have to be the same. So 4A plus 11 equals 27, which means then that 4A would equal 16, A will equal 4. And our final one like this, because each of these is 60, we know that BD is the perpendicular bisector, which means that 60 plus 3 and 10 to the minus 25 have to be equal. Okay, we'll subtract the 60, add the 25, and D will equal 7. All right, so as we scroll down then, we have one final picture here. So use the diagram for the following problems. Okay, so it says suppose AC equals 24, and one other thing I forgot is we got a right angle here and a right angle here. So if those two are both right angles, then we know that since those are perpendicular and these two from B to A and B to C are the same, that means that F is the bisector, so AF and FC will have to be the same. So if AC was 24, we can divide that by 2, FC will be 12. Now on the next one, it says suppose AB equals 14. So this AB is 14. What is BD? You see these marks, they would all be the same, so 14 and 14 will be 28. All right, example 4, it says WX is the perpendicular bisector of YZ. Okay, so if WX is the perpendicular bisector of YZ, I'm going to draw this situation for us. So WX is the perpendicular bisector, here's YZ, and WX we know is the bisector. Now it tells us that WZ So this distance, WZ, is 2x plus 11. Also tells us that WY is 4x minus 5. And I didn't put enough marks on here. If WX is the perpendicular bisector, we know this is a right angle, and each of these has to be the same. So if that is the case, hopefully you remember, that means that WY and WZ will be equal. Okay, so now I can't just put one mark on each of these because that would say it was the same as those. Instead, I'm going to put 2 marks because they are the same as each other. So 4x minus 5 equals 2x plus 11. Okay. We subtract the 2x, add the 5, so 2x equals 16, which means x will equal 8. All right. Our final thing we're talking about here, it says, if a line is perpendicular to one of 2 parallel lines, then it's perpendicular to the other line as well. Okay, so here we have a perpendicular line to the parallel lines, which means it has to be perpendicular both because 90 and 90, these are corresponding angles. So our converse of the corresponding angles theorem allows us to know that. So if we look here, we always know we start our proofs with the given. So A is perpendicular to T. That symbol right there, that upside down T, means perpendicular, much like that means parallel. Okay? And B is going to be perpendicular to T, and this is because it's given. Now we also can look here, and if A and T are perpendicular, then what do we know about 1? Hopefully you guys know angle 1 is going to be 90 degrees. And that's just our definition of perpendicular lines. Right, now angle 2 we also know will be 90 degrees because B and T are perpendicular, so same thing, definition of perpendicular lines. And then finally, that allows us to know that A is parallel to B. 1 and 2, as we just mentioned, up to the right, they are corresponding. So it's the converse of the corresponding angles because they are congruent. We know that it works. Okay. Now, on your Delta Math today, the first problem, I want you to look and watch as I do it with you. So you're going to be asked to do this twice. Construct a perpendicular bisector. So if you want, you can pause the video, open up Delta Math. Notice it says use a compass and straight edge to construct a perpendicular bisector. So the first thing we're going to do is click the compass. And we click on either endpoint, Q or R, and I'm going to drag it over halfway. Okay. Now from here, I simply click on the arc and draw halfway around. Okay. Now I move the compass. I don't move the sides. I just click on the center and I'm going to move it to the other endpoint. So I'll click it and drag it to R. I cannot change its size or else it will not work. And then I draw again where they will intersect. And now notice up here it says the final answer should be one blue line, not a line segment. So we need to make sure we use line. If we use line segment, it'll count it wrong. So I click on the line. I'm going to go from this point to this point where they intersect. This forms a perpendicular bisector. Right angles formed here, and it cuts halfway through Q and R. So we submit it, and we're done. If you need help on that, please let me know. Hope you guys have a great day. Finish up the Delta Math. Just so you know, if you weren't in class today, there is a quiz on Wednesday. Okay, hope you guys have a great day.